welcome back. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology. As part of MLRIT video lecture series, I'm going to discuss a topic in data mining, that is why we need to pre-process the data. So as we discussed in the previous sessions, the importance of pre-processing data science projects. So here in this session, we are going to discuss what is data pre-processing, what are the key reasons to pre-process the data, and what are the different methods to pre-process the data. And next session will go in detail about each pre-processing technique. As we already discussed in the very beginning sessions, like where we are getting this huge amount of data, and what are the different V's of data, like variety, volume, velocity. And the variety is going to play the major role in this part, mainly because the data is coming from the different sources and which is not in a unique format that is available in the form of audio, video, text, etc. And that is also not in a required format. So that is a major challenge. So today's real world databases are highly susceptible to the noisy, missing and inconsistent data due to their typically the huge size. That is like IDC predicted by 2025 the digital universe is going to have the 175 zettabytes of data. This is a huge in size. So that is one of the major reason, and they're likely, and the data, this 175 zettabytes of the data, the huge volumes of the data, that is originated from the multiple and heterogeneous sources. As we already discussed in the previous lectures, what are the different data sources, what format of the data we are getting from the different sources, etc. So if we give the low quality data and then the low quality mining results we will get. So we have to concentrate on this pre-processing. That's why I said many times in the previous lectures also. So any data science project or any data science team would spend around 70 to 80% of the time in pre-processing the data. So here you can see this IDC predicted the annual size of this global data sphere. By 2025 we are going to reach the 175 zettabytes of the data. So we already discussed how big this zettabytes, exabytes, petabytes in the earlier previous lectures. So how here, and before we discuss what are the different types of methods to address this issue, pre-process the data, and first we will get we have to ask a few questions, mainly how the data be pre-processed in order to help improve the quality of the data and consequently of the mining results. And the second question, how can the data be pre-processed so as to improve the efficiency and ease of the mining results? And if you look at the definition of a pre-processing, the data pre-processing be referred as the techniques. We apply the different techniques to the raw data to prepare it for the further analysis and modeling. So in the previous lectures, we already discussed about like in the pyramid, like knowledge, data, information, wisdom. What is the correlation? How this, like the raw data would be transformed into the wisdom. And the main goal of this pre-processing is to improve the quality of the data so that we could enhance the model performance and ensure the accurate predictions. And if you look at the data quality, and there are majorly there are 6 data quality measures, like validity, timeliness, consistency, uniqueness, completeness, accuracy. So these are the the major data quality measures, because every industry organization need to meet the standards, and they have to maintain the data in such a way so that they have to meet the criteria like the accuracy, completeness, validity, consistency, uniqueness, timeliness, and fitness for the purpose. So, and it is critical to all the data governance initiatives within the organization. So, the data have the quality if they satisfy the requirements of the intended use. So, the data quality standards mainly ensure that the companies are making the data-driven decisions to meet their business goals. So, if the data has issues like such as duplicated data, the missing values, outliers are not properly addressed, and the businesses increase their risk for negative business outcomes. So, we can also see that according to the Gartner's report, the poor data quality which cost the organizations around $12.9 million per each year. So, what is the correlation? What is the correlation between the data quality, mainly the three terms like a data quality, data integrity, and the data profiling? So, the data quality is a broader category of criteria that organizations use to evaluate their data for accuracy, completeness, validity, consistency, uniqueness, timeliness, and fitness for the purpose. And whereas the data integrity, it is a subset of these attributes in this data quality. Mainly, accuracy, consistency, and completeness these are the three major attributes. And then coming to this data profiling, it's again a process of reviewing and cleaning to meet the industry standards. And what are the key reasons to pre-process the data? Because before we apply any data mining technique, or before we perform any exploratory data analysis, or before we apply deep learning or machine learning or any AI algorithms or models, so we have to address the issues like the noisy data need to be addressed, and we have to handle the missing data, and we have to ensure that whether the data is a consistency, and then we have to, because our primary objective is to improve the model accuracy, and then the feature scaling. So these are the key reasons to pre-process the data. So basically removing the noise, that is, we have to identify and eliminate the outliers and the irrelevant data. So because as I said, so most of the raw data would have the much irrelevant data. So that irrelevant data need to be eliminated, or need to be processed, need to be addressed, so that we can remove the noisy data. In the next lecture, we will discuss in detail about how to remove this and how to address all these issues. And second one is how to handle the missing data. So missing data means like a fill or the remove missing values to avoid the biases. Like most of the data, like suppose if you take a movie, IMDb movie rating data, so most of the fields would be empty because most of the customers would not show the interest to give the feedback. And if you make it as a mandatory, then they will enter some default values. So that is completely invalid. So then ensure the consistency, that is we have to get the data that is in a standardized format. And for example, we already studied in database like how the database leads to the inconsistent state, how to bring the database into the consistent state. So we'll discuss all this in detail in the next coming sessions. So next, as we already discussed, the main objective of the pre-processing data is to improve the model accuracy or the decisions or whatever the insights derived. And the next key reason to pre-process the data is feature scaling. That is the influence of the different features in a data set, and how to normalize those data sets and how to standardize the data set. So to ensure the models to treat all the features equally. And if you look at like the noisy data, like identifying, eliminating the outliers and relevant data. And and this is the diagram which depicts the outlier. So which is an extreme value at a data point which has completely different characteristics of the behavior compared to the rest of the data points in a data set. And the data pre-processing steps are broadly categorized into the 4 categories mainly: the data cleaning process, data transformation, data reduction, data integration. In this data cleaning process, we are going to handle the missing data and we are going to correcting the errors. And whereas in the second approach, that is data transformation, where we apply this normalization, scaling, encoding, categorical variables, etc. And the third approach is data reduction. That is because most of the data sets may have the many number of features. So all the features in a data set may not be equally important. So that depends upon the limitations. Like suppose if we have the storage limitation, if you have the computational limitations, so then we have to go for reducing the data sets. That is called as a dimensionality reduction. So mostly we focus on the feature reduction, that is reducing the number of attributes of the features instead of reducing the samples. So then the fourth approach is the data integration. Here we already discussed in the previous session when the integration mainly used in a data warehouse building, because to bring the data into the data warehouse, and we have to extract the data from the different sources, and then we have to perform a process called as a ETL, extraction, transformation, loading, and then store into a database type of data warehouse. So here we are going to integrate, like suppose this data source could be like a web related, and this could be like a relational database, this could be some other databases. So in this data warehouse, what we will do, we will integrate the data from the different all these different sources and convert into the required format and store into a place called as a data warehouse. So these are the types of data pre-processing. We'll discuss in detail in the coming lectures. And just if you look at this, how we handle the missing data, like the most of the time, like suppose it depends on the quality of the data. Like sometimes we remove the rows and sometimes we remove the columns, because the rows may have the missing data, the columns also will have a missing data. So but the major risk of removing the rows or columns is a risk of losing the information, because sometimes and to get some observations would be very difficult. If you remove that, and we would lose this more valuable information, because sometimes it is very difficult to get that kind of data. So always it may not be the best option to remove the columns or the rows. And then the second approach, suppose if the first is not the option, then we'll go for the second option, that is called as a imputation. That is replacing the missing values with the central tendencies like a mean, median and mean medians. So then again we cannot directly randomly use either mean or a median to replace the missing values. We have to use the appropriate central tendencies so to replace the value, so that we will get the more relevant, the value that is we are going to replace will be the more relevant to that data set instead of a completely irrelevant. And then the predictive imputation, next option that is to handle this missing data is a predictive imputation. So we use algorithms to predict the missing values, because as a human being, like suppose if the data set is huge, like let us say some 1 lakh records, and if there are some 30% of the data, the 30% of the samples have the missing data, it would be little bit difficult. The number of samples or the data set size is large, and it would be very difficult to handle this missing data manually, because we cannot fill, and even if you are while filling this missing data, the typo errors also could happen. So that is not always recommendable. If the data set is very small, but most of the time we will not use the small data set for any applying any modeling or for performing any exploratory analysis or any further analysis. So we always use the different techniques. And here, like suppose if you check this, suppose the deletion is the first option, right? If you want to go for deletion, then again you need to check the percentage of the data you are going to delete, or the data set is having a 25% of missing data or more. So there are some limitations, we have to follow that. So that we can use any one of this approach, like a deletion or a imputation, that is replacing the missing values, or predicting imputation. So predicting imputation, again we use the different techniques to predict, okay, because the accuracy of the prediction depends on that particular model. So based on the model accuracy and the relevancy, we can use that particular model to predict the missing values. And next one is a data normalization and scaling. That is the mainly the normalization mainly transforms the data to the specific range, that is mainly from 0 to 1. This is mainly essential for the distance based algorithms like k nearest neighbor algorithms. Next, another approach is a standardization approach. Where the center the data around a mean of 0 and a standard deviation of 1. Like suppose we will, like, let us take the data, and if the data distribution is like this, and let us say this mean value is 0, okay, so we have to bring the mean value of 0 and the standard deviation of 1, so that based on this we can transform the data. We could apply this. Here you can see, like, this is one data set which I obtained from the Better Life Index, and this is the data I plotted, and the left side diagram shows, here you can see there is only one vertical line which is only and there is a overlapping line also there, like some other color like a green color, and the rest of the data points we cannot see on this. So this is the before applying the scaling, because one value or the very few features, the value range is very high. So that's why those two features or the very few number of features are dominating the rest of the features. So that is if you plot the data before the scaling. But if you could apply this mini-max scaling, this is the right hand side, the diagram shows the plotting, right? Plotting after applying the mini-max scaling approach. So we could able to see all the features in this. So that we will discuss in detail in the later coming sessions. Don't need to worry. And next one is the encoding data, mainly because as we discussed in one of the previous lecture, that is attribute categories. And based on the characteristics of the attributes, we need to handle or we need to apply the specific technique to transform the data or to handle the missing data, etc. Here we used like a encoding that is mainly for the categorical data. This one among this is a label encoding, that is to assign the numerical values to the categorical values, because most of the data mining or the machine learning or deep learning would always demands the data in the form of numerics. So we have to convert the categorical data into the numeric. And then second approach is called as a one-hot encoding technique, so which converts the categorical data into the binary vectors, that is mainly used for the ordinal. non-ordinal data. Here you can see a simple example which shows how the label encoding would be and how the one hot encoding would look like. Here you can see the food name, apple, chicken, and broccoli, and the categories. We are given the numbers like 1, 2, 3 and the calories corresponding, and this is a labeled encoding, and you can see that this labeled encoding data would be transformed into the one hot encoding, so that we can see like everything like apple under this 100, this would be a binary vector, and chicken 010, and that is also represented in the form of a binary vector, broccoli, etc. So we will discuss all this with a lot of examples in the coming sessions. And next, another thing is removing outliers. As we discussed in the beginning, remove outlier is an extreme value which need to be handled carefully. So because outliers can distort model training and lead to the overfitting or underfitting. And next, another methods we use to handle this outlier data like a Z score, interquartile range, box plots, and detector, and remove the outliers. And then just before 2 minutes back, we discussed about the importance of the features, why we reduce the features, because too many features can lead to the overfitting and the high computational cost, and that also we'll discuss in detail. And one specific method like a principal component analysis or the correlation analysis will be used to select the relevant features. So the pre-processing of the data would improve the quality of the models and reduces the overfitting and removing the noise and the irrelevant features. So that leads to the faster training and better generalization on the mainly unseen data. So coming to the conclusion of this session, so we have discussed the data pre-processing. So that is a crucial step in a machine learning and data mining and other data science approaches, and it ensures mainly that the data used is clean, accurate, and in a form that is more suitable for the model training, and mainly improves the overall quality and the readability of models predictions. So thank you. In our next session, we will be going to discuss those 4 data pre-processing techniques.